Hello everyone. Today we learn an interesting topic, that is unraveling the mysteries of the physical layer. Now tell me, what is physical layer? The physical layer is the first and lowest layer of the open system interconnection. The physical layer's function is to transport data using electrical, mechanical or procedural interfaces. In physical layer, there are many subtopics, but in this session, we will discuss some topics like data and signal, transmission impairments, data rate limits, and the performance of physical layer. Let us see first topic, that is data and signal. What is data? Data is the information we want to transmit. It acts as payload of carrier. There are two types of data. First, analog data. Second, digital data. Analog data. Analog data is continuous data that keeps changing over time. For example, in an analog watch, the hour, minute, and second hands keep moving, so you infer the time by looking at it. It keeps changing. Now, digital data. Digital data is discrete data. It can take only finite number of values from some alphabet, such as letters or digit. For example, 12:20 am, 5:30 pm, etc. at a particular moment of time. Let's learn about signal. Signal is the waveform format used to send data over channel. It acts as carrier which carries data or payload. There are two types of signals. First, analog signal. Second, digital signal. Analog signal. An analog signal can have infinite number of values in a given range. There are two types. First, simple analog signal, and second, composite analog signal. Now you will be thinking, what is simple analog signal and composite analog signal? Simple analog signal. A simple analog signal can be represented in form of sine wave. A sine wave is shown in the above diagram. A simple analog signal is smooth, consistent and continuous. As you can see in the above diagram, that an arc above the time axis is followed by the similar arc below the time axis and so on. Now, composite analog signal. Unlike sine wave, which is smooth and consistent, composite analog signals or waves are not smooth and consistent, which means an arc above the time axis doesn't necessarily followed by arc below the time axis. You can imagine them as a group of sine waves with different frequency, amplitude and period. Now, digital signal. Similar to analog signals, data can be transmitted in form of digital signals. For example, a data that is converted it into a machine language such as 1001 can be represented in form of digital signals. 1 represents high voltage and 0 represents low voltage. Now quickly go through the transmission impairments. Transmission impairment occurs when the received signal is different from the transmitted signal. As we know, a signal can be transmitted as analog signal or it can be transmitted as a digital signal. In analog signal, due to transmission impairment, the resulting received signal gets different amplitude or the shape. In the case of digitally transmitted signals, at the receiver side, we get changes in bits. There are various causes of transmission impairments. First, noise. Second, distortion. Third, attenuation. Let us understand them one by one. Noise. Noise is the major factor for the transmission distortion, as any unwanted signal gets added to the transmitted signal, by which the resulting transmitted signal gets modified, and at the receiver side it is difficult to remove the unwanted noise signal. These noises are various kinds like short noise, impulse noise, thermal noise, etc. Noise is diagrammatically represented as follows. Distortion. This kind of distortion is mainly appearing in case of composite signals, in which a composite signal has various frequency components in it, and each frequency component has some time constant which makes a complete signal. Distortion is diagrammatically represented as follows. Attenuation. Attenuation is generally decreased in signal strength, by which the received signal will be difficult to receive at the receiver end. This attenuation happens due to the majority factor by environment, as environment imposes a lot of resistance and the signal strength decreases as it tries to overcome the resistance imposed. Attenuation is diagrammatically represented as follows. Now second last point is data rate limits. The maximum data rate, also known as the channel capacity, is the theoretical limit of the amount of information that can be transmitted over a communication channel. The maximum data rate for noiseless and noisy channels can be calculated using Shannon's theorem. There are some uses of data rate limits. First is data rate is used to measure how fast data is transferred from one point to another. Second, it refers to the actual amount of data transferred. Third, it refers to the fastest possible data transfer speed. The last one is performance of physical layer. The physical layer maintains the data rate. It performs the synchronization of bits. It helps in transmission medium decisions. Its role is determining how physical connections to the network are set up, as well as how bits are represented into predictable signals, sending computer bits from one device to another along the network. I hope the session was informative and you enjoyed it. Thank you.